So this is the Unit 3 test review. We're going to go through all the different problems. Please make sure if you have a question about something that you come to a Zoom and ask me so that we can make sure that you are doing well. All right, we got a couple of these rational function graphs first. All right, first thing you got to do is factor everything. So in the first the first equation, we can take a 4 out of the top, our numerator. We're going to have x minus 2 left over. On the denominator, we have x plus 3 and x minus 2. We can then cancel out the x minus 2's. So we have 4 over x plus 3 left over. Okay. So now for our y-intercept, we're going to take the numbers at the back end after you put 0 in for all the x's. If you had 0 for the x's, it would look like this. It would be 4 over 0 plus 3. So you're going to have 0, 4/3. Please make sure you put this answer in the form of a point. Okay, so I'm going to put over here our y-intercept. It's going to be over 1, so it's going to be like right there. All right, your x-intercept, you're going to take the numerator and set it equal to 0 and solve. So 4 equals 0. Well, that's not true. It's not a true statement, so there is no x-intercept for this problem. For the vertical asymptote, we're going to take the denominator, x plus 3, and set it equal to 0, and solve for x. So x will equal negative 3. So we have right here is our vertical asymptote. Excuse me. Your horizontal asymptote is the first terms of each numerator and denominator. So we have 4 over x. Okay, if you put a really big number in for the x on the bottom of your denominator, it's going to be really close to 0. So it's going to be y is equal to 0 is our horizontal asymptote. I'm going to draw that in here. Next we go to the holes. We canceled out x minus 2. So we're going to solve that for x, which gives us the x value of our hole, which is 2. All right, and then we're going to use that 2 into our equation to find out what the y value is. So we have 4 over 2 plus 3, which gives us 4 over 5. So our hole is going to be at 2, 4 over 5. 1, 2, 4 over 5, there's our hole. Now for sign analysis, we have a hole and a point on the right-hand side of our vertical asymptote, but we have nothing on the left. So I'm going to make up a number, -5, on the left of our vertical asymptote. I'm going to put that into our equation. We have 4 over -5 plus 3, which gives you 4 over -2, which is -2. Okay, so -5, -2 is going to be our other point. And now that we have enough points on either side of our vertical asymptote, we can draw our graph. Making sure very carefully that we do not go through a hole. We jump over it. And there's your equation and your graph. All the information is going to be graded. So please make sure you show all the things you're supposed to show. The asymptote should be on your graph. On the coordinate plane, you should have the points, the lines, all right, all this other information appropriately. All right. Number 2. All right. So we're going to factor these. You have x, plus 4 and x minus 1. On the bottom, you're going to have x plus 2 and x plus 4. The x plus 4's will cancel out. You're left with x minus 1 over x plus 2. Excuse me. For the y-intercept, we're going to put zeros in for the x's. So you have 0 minus 1 over 0 plus 2, which gives you 0, -1/2 for your y-intercept. So let's graph that. All right, for your x-intercept, we're going to take our numerator, x minus 1, set it equal to 0. So your x-intercept is going to be 1, 0. All right, your vertical asymptote's the denominator set equal to 0. So you're going to have x equals -2. Draw that in there. Your horizontal asymptote is going to be the leading coefficient of the numerator and denominator, which is x over x, which is equal to 1. So y equals 1 for your so your horizontal asymptote, rather. Okay. For the holes, we cancel out x plus 4, so that's what we're going to use to start the first part of our hole. Set that x plus 4 equal to 0 and solve for x, which is negative 4. All right, now we put negative 4 back into the x values of our equation. And it gives us negative 5 over negative 2, which is positive 5 over 2. So we have negative 4 and 5 over 2, which is 2.5. There we go. Okay. Now for sign analysis, we have 2 points on the right side of our vertical asymptote, and we have the hole on the left. So we don't need this. Okay, so we're going to draw our graph now. Again, being very careful to not have the line go through the hole. And graph that. Again, please make sure you put in the horizontal and vertical asymptotes where they belong, and all the points and the holes. All right. Last one of these, yep. All right, just kind of like the first one, we had a 3x plus 9. We can take a 3 out, get x plus 3 left over. Okay, on the bottom, we're going to have x plus 3 and x plus 2. The plus 3's go away. We're left with 3 over x plus 2. For the y-intercept, we have 3 over x plus 2, so it's 3 over 0 plus 2, which is going to be 3 over 2. Go here and find 3 over 2 as our point, which is 1.5. For your x-intercept, 3 equals 0, which again is not a true statement, so this is not going to have an x-intercept. Your vertical asymptote, you have 3 over x, which is going to give you y equals, oops, sorry, that was a mistake. I did the wrong one first. The vertical asymptote is the denominator, x plus 2 equals 0. So x equals negative 2. Got a little bit ahead of myself. All right, now the horizontal asymptote is 3 over x, which will give you, if you put a really big number in for x, it's going to give you something close to 0. So y equals 0 will be your horizontal asymptote right on the x-axis. Your holes, what got canceled out? We cancel out x plus 3. So you're going to have negative 3 as the x value of your hole. Put that into your equation. So you have 3 over negative 3 plus 2, which gives you 3 over negative 1, which is, again, negative 3. So negative 3 comma negative 3. It's right there. Oh, that's a hole, sorry. Where my mind went. Okay. Now, for sign analysis, we don't need one because we have a point on the right-hand side of our vertical asymptote and a hole on the left. So that's all we need to have to be able to graph our equation. Again, making sure that you have drawn the asymptotes and that you don't go through, the line does not go through your hole. All right, that is the examples for rational functions, graphing them. Next, we got the composite functions, the most recent thing we've done in class. So we're putting these values, or whatever you have to do, into the functions that you're given. So we have f of negative 7, so we're going to put negative 7 in for the f function. So we have 2 times negative 7 plus 1, which gives you negative 14 plus 1 is negative 13. G of x plus 1, so we have 3, replacing the x value with x plus 1 and squaring it. We're going to actually multiply this out. So we're going to get rid of the squared part and replace that with x plus 1 because we're multiplying x plus 1 times itself. Excuse me. So we have, I'm going to make this bigger, x squared plus x plus 1, all of that times 3. If we combine the like terms and multiply by 3, we'll get 3x squared plus, there's 2x's, times 3 is 6x plus 3. And that will be your final answer for number 11. So g plus h of 6. So we're going to put, in the g function, we're going to put 6. So 3 times 6 squared. And we're going to add that to the h function. So we have 6 squared plus 2 times 6. So we're putting in 6 for all the x's in both functions. I just got to do the order of operations to make sure we get this right. So 6 squared is 36 times 3 plus 36 again, because it's 6 squared, plus 12, 2 times 6. We get 156. All right, it is important that when you're doing these problems that you show the work. Showing the work is showing how you're putting the numbers or the expressions into each function and how it's being set up. If it's set up correctly and you get the wrong answer, at least you can get partial credit. If you just give me the answer with nothing else in it, you're probably going to get 0. All right. Now we have g minus h of x, which means the x is being replaced by an x, so you're not changing anything with the functions. You're just subtracting them. So 3x squared minus the h of x is going to be, you got to put this in parentheses because that negative sign is being distributed to all the terms in the h function, plus 2x. So 3x squared minus x squared is going to be 2x squared, and then negative times 2x squared is negative 2x squared. Or sorry, just 2x, sorry, no squared on that one. And that's it. All right, f of h of negative 1. So what we're doing is putting negative 1 in for the the h function first. So we have negative 1 squared plus 2 times negative 1. All right, we're going to figure out what this is. So negative 1 squared is 1, plus 2 times negative 1 is negative 2. So we got 1 plus negative 2 is going to be negative 1. All right, so now we're going to put that value into the f function. So we have 2 times negative 1 plus 1. It's going to be negative 1 again. All right, number 15 says kind of the same thing. It's just a different format for the composite functions. Putting 0 in for f. So we have 2 times 0 plus 1, which gives us 1. And we're putting that in for the f function again. 2 times 1 plus 1 will give us 3. And that is our answer. All right. H of negative 3. So we're going to put negative 3 in for the h function. So we have negative 3 squared plus 2 times negative 3. All right, and that will give us 9 minus 6, which is 3. Now we're putting that value back into the h again. So we have 3 squared plus 2 times 3. And that's 9 plus 6 is going to be 15. All right, we're putting 10 in for the h function. So we have 10 squared plus 2 times 10. So that's 100 plus 20, which is equal to 120. And then we have the f function is 2 times negative 1 plus 1, which gives us negative 1. And we're subtracting those two things. So we have 120 minus negative 1 gives us 121. And finally, 18, we have g of x of h of g of x. Sorry, it's h of g of x. So we're putting the g of x function inside the h function. So all these x squareds, or sorry, all the x's in the f, I'll get it. All of the x's in the h function are replaced by 3x squared. So we have 3x squared being squared plus 2 times 3x squared. Okay. So you have to square all these things. 3 squared is 9. X squared squared is you're multiplying the exponents. You have x to the 4th plus 6x squared. And that is the answer for 18. Okay, those are the composite functions. Next we get into the logarithms. So we want to write an exponential equation and then solve. So we're going to smash the log. The 4 becomes the base for the exponent of 2. And that equals x. So 4 squared is 16. All right, for this, you want to rewrite the exponential equation as a logarithmic equation. So that means the base is 5 at 125, and the exponent was x. So you're basically being able to go back and forth between 20 and 21. Here we're going to condense the logarithms because the both bases are 4. That's possible. So we have log base 4, right? And then 5 times, this 3 has to become the exponent on x, so it's going to be x to the third. Here we want to expand. So you have log base x. We're going to have two separate terms. We have 6 and y squared. So we're going to have log base x of 6. And then because they're being multiplied, 6 and y squared, you're going to add log base x of, actually, I lied. That 2 is going to become a coefficient. So it's 2 log base x of y. Okay. Condensing these two, so we have natural log of 5. Since it's minus, you're going to divide 5 over 3. And then here, last one, you have natural log of 4 plus natural log of x minus natural log of w. So the 4 times x, that's going to be split up and be a plus, and because it's being divided by w, it's going to be a minus natural log of w. All right. So this is kind of a little bit of both things that we just did with condensing and then solving the equations. So we have log of 5 times 20 equals x. All right, remember that base, since it's not listed, is 10. So we have 10 to the x power equals 100. So x will equal 2. In 27, we have to combine these solve this by changing the bases. All right, we change 16 into 4 squared because now the 4's are the same, and 4 squared is 16, so we're going to change 16 by using exponents. Then we have x plus 1 equals 4 to the x minus 7. All right, now with the exponents of 2 and x plus 1, we have to multiply that. So we're going to have 2x plus 2 equals x minus 7, and we can get rid of the bases then. We just solve this for x. So we subtract x, we get x. We subtract 2, we get negative 9. There you go. In 28, the bases are already the same. You can just cross them out. So you have 3x plus 4 equals 4x minus 6. We subtract the 4x, you're going to get negative x. You subtract the 4, you get negative 10. So x will equal positive 10 when you divide both sides by negative 1. All right, 27 can be changed bases by doing 3 to the third raised to the 4th power. Okay. When you multiply the exponents, you'll get 2x equals 12 because the bases will go away, and x will equal 6. And then lastly, we're doing the problems where you have to actually use logarithms. All right. So we're going to have x log of 3 equals log of 8. So we're placing logs in front of both terms. The x as an exponent becomes a coefficient. Now we can divide both sides by log of 3. Okay, it is very important to use the parentheses correctly, like I showed you in the video for solving these types of problems. All right, I'm not going to jump back and forth because I don't really feel like that's a lot of movement. So I'm just going to do it on my calculator and then give the answer. If you're having problems with that, try it on your own and see if you can manipulate it so that it works the right way. So we have log of 8 divided by log of 3. I'm going to get x is equal to 1.89. Okay. Number 31. Again, the x becomes a coefficient for log of 4 equals 2 log of 7. Okay. Again, to solve for x, I'm going to divide both sides by log of 4. So I have 2 log of 7. And I'm going to divide that by log of 4 using parentheses. I'm going to get x is equal to 2.81. All right. In this case, I have that exponent becomes our coefficient, so 3x log of 5 equals x minus 6 log of 4. Now this case, this is a little more tricky again because you have that x minus 6 as your exponent, so you have to distribute the x and minus 6 to both logs. So you're going to get 3x log of 5 equals x log of 4 minus 6 log of 4. Okay. Now we have to get the x's both on the same side so we can factor them out. So I'm going to subtract x log of 4. So I have, these will go away. I have 3x log of 5 minus x log of 4 equals negative 6 log of 4. Okay, and the reason I did that is I need both x variables on the same side of my equation. Okay, and the reason that is true is I have to take them out by using the greatest common factor. If I take x out as the greatest common factor, I'm left with 3 log of 5 minus log of 4. Okay, so then I can divide both sides by 3 log of 5 minus log of 4. Something I am forgetting to do is put parentheses around all this to help you out. Your x will equal, now this is going to be really important that you do this correctly in your calculator. You have negative 6 log of 4 divided by, you got to put parentheses around the entire bottom, 3 log of 5, close the parentheses around the 5, minus log of 4, and you should get negative 2.42 if you round up that 100th spot. All right, I know that was a little bit long. I do apologize, but it is what it is. All right, last one. We have x plus 1 log of 8 equals log of 20. Okay. Now, there's actually a couple ways you can do this. I'm going to be a little bit, I don't know, what's the word? A little bit different than the last one we did where we distributed it. We don't have two separate x variables to deal with in this case. So there is actually another way to do this problem. Since you're multiplying log of 8 times x plus 1, you can just divide log of 8 right away because it is being multiplied. Okay, and then what you could do is you have x plus 1 equals log of 20 divided by log of 8. You could subtract the 1. Okay, so it's very important, again, how you do this. If we have log of 20 divided by log of 8, then I have like equals, and then I can minus 1. And I will get x will equal 0.44. Okay, if you multiplied the log of 8 out and did it that way, that would work as well. It wouldn't make a difference. All right, but that does work. All right, and that brings us to the end of the review sheet. Please, if you have questions about any of the problems and how to do them, please make sure you come to the Zoom, any Zoom, either office hours or during class. Ask some questions, get some help, get ready for the test on Friday.